Now it is my great pleasure to introduce to you Annette Krop-Benesch, who studied biology at the University of Frankfurt Main with research visits to Australia, universities of Perth and Sydney. She studied activity patterns in zoo and wildlife animals, focusing on the influence of light and husbandry routines. In 2012 and 13, she was a public relation coordinator for the Loss of the Night project, which is a big light pollution project many of you have been involved in. In 2013, Annette and Chris Kaiba organized the first international scientific conference on artificial light at night, ALAN, in Berlin, which received a Dark Sky Defender Award from the International Dark Sky Association. She also helped to make the Loss of Night app become a reality, and I have that app on my phone and I recommend it, Loss of the Night. In 2016, she started the initiative Nachhaltig beleuchten, or sustainable lighting, to work as a freelance writer and lecturer and consultant on the impacts of artificial light at night on nature and human health. She's the author of a book, Licht aus, die unterschätzte Gefahr der Lichtverschmutzung, or Lights Out, the underestimated risk of light pollution, published in 2019. She works for ministries and national parks in Germany, Austria, Luxembourg, the Netherlands, as well as for companies and NGOs. She's a scientific advisor to the UK community interest company Make Light Matter, which is a member of the Loss of the Night network. And she's also a member of the German Lighting Society. Annette worked closely with me, I'm very happy to say, and with a dozen other experts from around the world on the Artificial Light at Night Working Group of the United Nations Dark and Quiet Skies 2 conference this past year, where she brought her deep expertise on the effects of artificial light at night on living creatures of all kinds to the United Nations. This issue, the negative effects of light pollution on the natural world, is absolutely central to our efforts to preserve the nighttime environment. Annette, thank you so much for joining us from your home in Germany on a weekend. And now please tell us more about the effects of light pollution on the natural world.
Thank you, James, for this kind introduction, and thank you for having me. It's 8 o'clock here in Berlin, but I'm really excited to talk to you, and I was really excited to listen to Nancy's talk. Lots of interesting things, and maybe I can add a few things talking about light, colors, and intensities. James originally asked me to give my talk from the UN, but I decided, since you're all kind of familiar with the topics, I don't have to go back to the basics with you. So I will give you some general ideas about why this all is important. And I picked a few studies which have come out recently, which I think are quite interesting for you and give you some more information you might feel helpful or might be helpful for your work. So now I'll try to, hold on, I'll trying to tackle this technology here and share my screen.
Let me know how we can help.
So, can you see it?
It's coming. There it is. We see it.
Great. Fantastic. Okay, then let's see if this works. Okay, yes. Well, I guess many of you are astronomers. Many of us love to look up into the night sky and look at the stars. And none of us probably has ever had this view in person. This is our home planet from space. Something great happened about 4 billion years ago. Life started. As far as we know, the first or the only planet where this happened. There might be more out there, but we might never find them. To have life evolving is a difficult thing because our planet changed a lot. The continents changed, the climate changed, the atmosphere changed, lots of things going on, and life forms had to adapt to this. And some of them did, and many life forms got extinct. This is part of evolution. Today we have a fascinating biodiversity, which is threatened by many, many dangers. One thing that hasn't changed in all these 4 billion years is the change or the difference between day and night. It is the fact that half of our planet is bathed in sunlight, which is pretty intense, while the other half is only lit by the light of the moon and the stars. And this is probably the biggest difference in external factors life forms have to go through, and this on a daily basis. And not all life forms are really adapted to do this in full. If we have a look at life forms, and I will start with animals because they're somehow closer to us, then there's quite an interesting thing going on. If you look at ecological niches, you quite often find that there are species that are exclusively diurnal and species exclusively nocturnal, but they're doing the same job. They have the same function. So we basically have in the same habitat a day shift and a night shift. And by this, we are having space for more species, for more life forms in the same place, which is a really neat thing. And it's not only the case in animals, it's also the case in plants. You might not be so aware of this. You might know that many flowers open only during the day, but there are also plants that open their flowers during the night or only produce pollen, for example, during the night. So they are actually nocturnal plants, which is an interesting thing. So life is adapted to this change. And it hasn't changed through these 4 billion years until 100 years ago, when we invented electric light or made electric lights like a general overall thing. And now we don't have this change between day and night anymore. What we do have is a night with dim lights, sometimes very bright lights. And if you look at certain spots, actually light that is almost as bright or maybe really as bright as daylight, if you go close to a light source, for example. And this changes the way life forms experience the nights in many, many ways, and you're familiar to many of those. Some species are attracted to the light, others avoid it. We have changes in habitat use. We have changes in circadian rhythms, like some diurnal animals being active even during nighttime. Many nocturnal species or some nocturnal species be not able to be active while it's brightly lit. We have changes in migrations. We know this from birds. We know this from different fish species. We have direct impacts like glare. We have impacts on health. And we even have impacts on seasonal rhythms because the seasonal changes of day length is very important. And we're taking this away with the illumination we're putting out there. So many, many factors that are affected here, many processes affected here in plants, animals, and also in bacteria, in fungi. Basically, every light form we looked at has some relation to light. Now, I could talk hours about this. I picked a few examples. And of course, I have to talk about insects. The attraction of insects to light is a pretty important thing. And here in Germany at the moment, the protection of insects is very, very important. Our government just passed a law making sure that light pollution has to be tackled to protect the insects, which is a great thing. Let's see how it works in the end. Now, there have been several studies on this showing that the higher the color temperature, the bigger the attraction to insects or for insects. And we've just heard from Nancy that going into lower color temperatures might not be the best thing for our vision or might not be too easily to realize or to make come true in many communities. And recently there was a new study done with some people from ecology and also some lighting planners and lighting engineers. And they compared in Switzerland 6,500 Kelvin LEDs with 2,700 Kelvin LEDs. And the strange thing was they couldn't find a difference in attraction. They were both equally attractive to the insects. And they were a bit surprised what was going on here. And one idea they had was they didn't put out these street lights. They used them in areas that had been lit for several decades. and they didn't catch many animals, many insects. So they wondered if maybe all the light sensitive insects had already gone. This is a theory they can't really prove, but we have to keep this in mind when we look at these studies. They didn't stop there. They went a bit further. They did a follow-up study. On what they did now was they compared 4,000 Kelvin, 3,000 Kelvin, and amber LEDs with each other. They didn't find a difference between 3,000 and 4,000, but they found one with the amber LEDs. The amber LEDs indeed attracted significantly less insects. But if you compare that to the dark control, to the area without lights, it's still a lot. So amber LEDs still attracted many, many insects in this area. So maybe amber LEDs aren't the solution to our problem. But they did something else. They looked at the shape of the light, the way the light was distributed from the LEDs. And they tried two things. They tried LEDs that directed the light onto the streets, and they used LEDs with diffusers, where the distribution of the light would more be what we know from the HPS, for example. So a wider area of airspace would be illuminated. And here the difference was bigger than if they compared the different color temperatures. So what they found here is the better directed the light is, or the smaller the actual area in the air that is illuminated, the less attractive the light is for the insects. And they tried something else, and this goes into Nancy's direction. They dimmed the light. They actually looked at how much traffic is there in different times of the day or the night, and they dimmed the lights. And they found that with dimmed lights, actually less insects were attracted. That's not true for all insect groups, and there are always differences between the insect groups, but overall, what you could see is with dimmed light, you simply had less insects at the same color temperature. So what is the takeaway message from these studies they did? The first thing is there is no insect-friendly light. We have to be careful with people who say, oh, I'm putting up amber LEDs, and they say it's insect-friendly light, so it's fine. It's not so easy. Even amber LEDs have a high impact on insects. We have to consider, where do we need light? And when do we need light? So dynamic lighting, in what way we're using, is the right way to go. Aside from the fact that we definitely have to ask ourselves, do we have to illuminate all the spots we're illuminating? We should use the lowest possible intensity, and we just heard that this can be quite low. So we should really try to figure out how low can we go to give people a safe feeling and to have actual objective safety. We have to reduce the lit area. That means we have to construct nice beams, and Nancy has also shown that with LEDs this is possible if you have a good lighting planner. And if you want to top that, you can use amber LEDs, which might not be a problem of safety if, for example, you use it somewhere where there are no cars, where there are only pedestrians, for example, where you don't have to react on objects that fast as you have if you're on the street, for example. For example, talking about parks, although we should ask ourselves, do we have to illuminate all the parks at night? So in terms of insects, these are ways to reduce the impact of light. However, this attraction is not the only problem insects have with light. It's going into physiology also. There's a very interesting study area in the Netherlands where they have studied insects for a long, long time. And what they found is that moths, if you put light into a forest area, they reduce their food intake, they reduce their general activity, they produce less pheromones, and they reduce their mating. And indeed, after 5 years, they found a reduction in the number of moths, and it was a reduction of 14%. This is quite a number. So we really have to consider putting light into areas that are more or less natural. Now, what about street lights? A few weeks ago, somebody else was supposed to talk to you, Douglas Boyce, who unfortunately, very sadly passed away, very unexpected. He was a young scientist, and James asked me basically to talk in his place. And of course, I would like to present his research. I didn't know him personally, but I think it's just fair. And especially, it's a really, really important research he did. Losing Douglas is a great loss because he did some great things. What did he do? He went around the UK and looked at streets that have been illuminated for quite a longer while. And he looked at the number of caterpillars. Different to moths, caterpillars can't choose where they are. They have to stay where they are born, and they have to stay there until they change into adults. So he looked at hedgerows and he looked at grass margins, and what did he find? He indeed found a reduction in the number of caterpillars in HPS lit streets, in LPS lit streets, and very strongly in LED lit streets. So aside from the question of attracting flying insects, there are signs, there is evidence that it also interferes with the caterpillars here, and that we also have a reduction in the number of caterpillars. And he found something else. He looked at the single caterpillars and he found that at least under LED light, they were heavier, they were larger. Now you might think that's fine. A larger caterpillar must be a healthier caterpillar, but that's not the case. Usually in caterpillars, if they are unnormally heavy, it's a sign of stress. They're trying to develop as fast as they can to get out of a stressful area or stressful location. So what we here see might be a sign that these caterpillars aren't happy where they are, which especially is here under LED lights. So another reason to believe that light is not good for insects. And insects aren't the only species, the only animals that have problems with light. There's been a nice study on common toads. Toads are part of the amphibians. Most amphibians are endangered worldwide, and there's lots of concern about protecting them. So what did they do? They looked at more or less natural light levels with 0.01 lux. They looked at dimly lit areas, 0.1 lux, and at areas with 5 lux. And this is actually not an uncommon light level in the habitat of a common toad. And what they found is the following. Usually when a male and a female toad come together, they check each other out. And if they find that they make a nice pair, they build a so-called amplexus, which means the male climbs on the female and she carries him to a pond where she lays her eggs and he fertilizes them. And usually when they found each other, they stay with each other until the eggs are laid. This is the normal way of life. Now, if you put artificial light into the game, they form this amplexus much faster, which sounds nice in the first moment, but they separate sometimes. And the separation rate is considerably higher, which means they make their choice too fast and find out later that it wasn't a good choice. And if you look at fertilization rate, you find it's not a difference at 0.1 lux, but at 5 lux, the fertilization rate of the eggs is actually smaller, lower than it would be under natural, in a natural situation. So this means that if you put light into a habitat, into a toad's habitat, their fertilization success, their breeding success would be reduced, which is not a good thing. Also, a problem with reproduction can be seen in mammals. And now I'm taking you to Australia. to the Tama wallabies. This is a really neat study that looked at mammal reproduction on a military base, which is illuminated the entire night. And they compared the wallabies there with the wallabies in natural darkness in the bush. And they looked at melatonin levels. And they found, not surprisingly, that the one at the military base with Alan had reduced melatonin levels. Now, melatonin is important for basically everything in our physiology. Without melatonin, our body doesn't work so nicely. Melatonin also plays a part in reproduction. And Tama wallabies are seasonal breeders. That means usually the young wallabies are born in the height of summer in January and February, or most of them. Here at the military base, with a constant day length, the births were pretty much distributed from summer even into winter. And winter in Australia isn't that cozy. And we're talking about South Australia here. It's cold. It can be snowing down there. So these young wallabies that are born in autumn, that are born in winter, they actually have a hard start into life and they might not make it. So artificial light can mess up the seasonal timing of breeding. And there's reason to believe that they are not the only mammals with this problem. We know the same problem from birds. Now, back to the States. A big problem we're having not only in North America, basically worldwide, we have the same problem in Europe, is we have a fragmentation of habitats. And one way we're trying to deal with this is we're trying to create wildlife corridors. And the big problem are roads. For everyone who uses this road. If we have, these roads can be a barrier for wildlife. Some wildlife might try to cross the road and nobody would like to collide with a deer. That's not a good idea. So we have these wildlife passages which are supposed to allow the animals to cross the road without getting into danger or without endangering anybody. Now, for some reason, some of these wildlife passages are actually illuminated. Sometimes they're also used by humans, but sometimes people have the idea that putting lights in there make them more attractive for animals. But for some animals, it has actually been shown that they will use these passages less or not at all. And some of these species are deer, several mouse species, and possums, like this really hardworking mom here. So if they want to cross over to another area and interconnect with other populations, if you put light in there, this might actually cut them off and makes it impossible for them to use a wildlife corridor. Now, these are some examples from animals. Let's look at plants. We have to put a bit more light on plants. Quite interestingly, there's lots of research being done on light in agriculture, but not so much on wild plants. You all know these pictures. They're rather typical. You have trees without leaves, but there are still leaves left around the luminaire. Or here you can see here right where the light is, it's nicely green, and up here it's brown. Why is that the case? Now, when we talk about light levels, we usually talk about the light level down on the ground, which might be 2 lux, 5 lux, 10 lux. We usually don't talk about the light levels here, which might be 3,000, 4,000, 5,000 lux. So this is daylight, which they actually get, and this all the year round, 24/7. So they miss the moment when the days shorten, and they miss the moment to prepare for autumn. This is also something farmers know. If you look at soybeans, this picture showed up on Twitter some weeks ago, and it shows very nicely what the problem is. These are soy plants, and you can see here next to the street lights, they're nicely green, which looks nice in the first moment. You have the feeling these plants are thriving, but the problem is to produce pods, to produce soybeans, they need a shortening of day length. Now, if they get light the whole night through, they miss the end of the summer, and they never produce any pods. So there's no yield for the farmer. This is actually also an economical problem for the farmer. So streetlights next to fields is not a good idea. And of course, we are talking a lot about pollination. This is a big thing, and you probably have heard a lot about that too. We do know that putting light onto plants can scare away pollinators. Plants or meadows that are illuminated at nights get less visits from pollinators, and they're less different pollinators. I don't know about the US. In Germany, everybody who talks about pollinators talks about the honeybee, but indeed, there are lots of moths and nocturnal beetles who are doing a great job, but they will stay away from the plants. Now, if plants are pollinated less, they will produce less fruits, they will produce less seeds, and of course, the next generation of plants will be much smaller. These plants, as well as the seeds and the fruits, they are food for insects, for example, like these aphids. The aphids are food for the ants, for ladybugs. They are food for birds, for mammals. And basically, by putting up light on a meadow, you scare away the pollinators and you upset the entire food web. And you also upset the ecosystem service that is provided here. These plants produce biomass, they produce food for the whole food web, and in the end for us too, because we rely on pollination. Next time you eat some fruits or vegetables, you have a fairly high chance that this has been pollinated by something. And the last example I want to show you, we're talking a lot about light pollution in cities and things, and you might think that our oceans are dark, but they are not. This is a picture taken from the ISS. This is Taiwan and China. And what you can see here, these are fishing boats. And they use immensely bright lights to attract fish. And there are actually regulations about how much energy is allowed to be used, at least in some nations. Others don't care, but there are no regulations on the amount of light that is put onto the ocean. Now, what's the problem of this light? It attracts fish, it attracts lots and lots of seabirds, but it scares away plankton, especially this zooplankton. Zooplankton spends its days in the deep sea because it shies away from light. Now, at night, when the sun sets, all the zooplankton comes up to the surface to feed on the algae up there and on the phytoplankton. And in the morning, it goes down into the deep sea, taking all this biomass with it. And down there, they are eaten by bigger fishes and bigger animals. So we have a transport of biomass from the surface into the deep sea. This is the biggest migration we have on Earth. It's much bigger than all the bird migration or the migration of big mammals in the Serengeti. Zooplankton doesn't do this when there's light around. So basically what we're having is an effect of light pollution on the deep sea life forms without light ever going down there, ever reaching down into the deep sea. So this is the reach of light pollution, which is pretty scary. And as I said, I could talk hours about this, but I don't have the time. So I've given you some examples. What I would like you to take away from this talk is one really important thing. When I talk to people about conservation of life forms, one example, everybody knows that if you have a wetland and you take away the water, the frog can't survive there because they need the water. What we have to understand, what we have to make clear to people is it's the same with darkness. If we take away the darkness from the night, nocturnal animals will lose their habitat, the habitat they're adapted to. They need the darkness of the night as much as, for example, the frog needs the water in their ponds, and we have to protect this darkness. Thank you.
Thank you so much, Annette. That last note, that last point that you made is one that that struck home so much with me when I first heard you make it a few months ago, that I have already incorporated it into my own messages. And everything you said, as I said for Nancy's talk, everything you said is so helpful in our common efforts. So appreciate your taking the time to pull all this together and to share it with us. We are behind schedule, but I would love to just see if there are a couple of burning questions, and then we can move on and continue questions in the chat. Although Annette, I'm sure that it's, you have to put your kids to bed. It's nighttime. You're not supposed to be up now, and so
it's not that late, and my husband is on duty tonight, so the kids are all.
Thank you, husband. Okay. Okay, are there questions? If you have questions, please raise your hand. And okay, I actually have lots, but I have an ongoing communication with Annette, so I'm able to reserve them. But I want to ask a general one that might be useful for people's efforts here. In your experience, you have a lot of experience in preserving the night and working against light pollution, and specifically from the biological angle. In your experience, and not just in Germany, but worldwide, what resonates the most? What are, you've been communicating with decision makers a lot. And in fact, do you find in general that it's the animals that people care about most? You said in Germany, it's the pollinators. Can you give us some perspective on how we can best incorporate this into energy saving and saving the stars and our general message?
Well, at the moment, insects are a big topic here in Germany, but I think also in other European countries. So this is something that strikes when you talk to politicians. If I talk to private people, I often like to talk about hedgehogs in the garden, because they're also affected by this light. They don't like the light. And something I find very, very helpful when I talk to gardeners is to tell them that if they put these little solar lights into their garden, they attract slugs. Nobody wants to have slugs in their garden. So I had a couple of gardeners going back home, rearranging their garden to get rid of the slugs. So it sometimes depends a bit on the group of people you're working with. It's always nice if you have cuddly animals like the Tama wallabies. That also strikes home. But to be honest, the best arguments I find in all my talks and all my seminars are not animals, but we humans and our health. The moment I start to talk about health issues and the fact that this light interferes with our sleep and interferes with our psyche, people start listening. And I find that there are many people out there suffering from the new street lights because they say they're too bright, too glary. They just intrude in their homes. And it's not only the bedrooms, it's also, we have illuminated gardens. And people feel a loss of control there. I think this is the best argument to talk to people, and we are animals too. So I always try to get people through our health and our well-being, and then I usually have them on my side.
Thank you so much, Annette. Again, I do have more questions, but I'm going to reserve them for now. And please join me again in thanking Annette for joining us today.